Welcome to math class. We are continuing on in the Math Makes Sense 9 textbook, looking at chapter 3.5. Oops, I already started off a little slow. So chapter 3.5 is looking at dividing rational numbers. So the other day we did multiplying rational numbers. Now we are looking at the inverse operation, or the opposite of division. Okay, before we get started, just a quick little reminder that we always have to be paying attention to the signs, or lack thereof, in front of any numbers we're dealing with. Same sign, positive, positive, or negative, negative, is going to always equal a positive number. Okay? When they have opposite signs, so if there's one negative and one positive, they're always going to have a negative outcome. Okay? Keep that in mind because sometimes it's a little it can be trickier to keep track of the negatives through all the steps of writing out the problem or solving the problem. And so oftentimes it's easier to save that till the end, to understand that if I'm looking at two numbers with opposite signs, I know if I multiply or divide them, they're going to come out with a negative sign. So I don't necessarily need to, oops, went a little far on that one. Don't necessarily need to keep track of that all the way through if I already understand at the end it's going to become a negative. Okay, so let's look at our very first example here. Now, if you remember, multiplying fractions is pretty easy. You're essentially just doing basic multiplication as written out on the paper. For this, we have a couple different methods for the way we can solve when we're dividing fractions. So, as mentioned, the first thing they want to do is looking at our sign. So I know that because I've got a negative here and a positive here, at the end, I'm going to have a negative number. Okay, so I know that already. So what I want to do, or one method for solving this, I'm actually going to blow this up a little bit so it's easier to see. Okay, so one method for solving this is laid out in the textbook. It's got an extra step in it, but it's a nice method, and it's rather simplistic. It really shows you a simple way to look at dividing fractions. So what we've got here is negative 5/8 divided by 3/4. And so what we're going to do is we're actually going to, similar to adding subtraction, I'm going to put them over common denominator. So I know that 4 goes into 8 2 times. So down here, what they've done is multiplied 3/4 by 2 so that you get negative 5/8 divided by 6/8. Now, remember, when we have our so-called normal numbers, 3 divided by 2 equals, we can also express that as 3/2. Okay, that should be review for most of us. So we're essentially taking that same method and now applying it to our fraction. So if we took those numbers and we could rewrite them as negative 5/8 over 6/8. Okay, except looking at that, you can already see that's going to start breaking some laws of the universe or something. We got fractions divided by fractions. Oh my goodness, well, the reason for that is because essentially we don't need our denominators. And remember, we're looking at a fraction. We're looking at how much of this can be broken down into different pieces or parts. And what we find is if we just take those two numbers and I arrange the top two numbers one over top of the other like we do with our so-called normal numbers, we get our final answer. Now, remembering that our opposite signs up here, so we're going to have a negative 5/6 as our final answer. So the steps there are basically to get your numbers over a common denominator, and then you take the top two numbers and arrange them into a fraction, and that is your final answer. It's a simple method, but it can be sometimes a little bit confusing. I find some students have troubles with that because it seems a little too simple. Okay, so what we're going to do here is look at another method, a different method of solving it, and one that shows how both of these methods work, or kind of proves that both of these methods work. Oh, my screen got a little fuzzy there. Okay, so in here on the textbook, they have, back this up a little bit, they have an example of -4 1/5 divided by -3 1/3. So we're going to stick with them for the basic part of it. So what they want to do is look at the sign. So I know that I'm going to have a positive number at the end. The next thing we do, because we have improper fractions, or sorry, mixed numbers, mixed fractions, I'm going to write it as an improper fraction. So I'm just going to make it easier to deal with. So I wind up with -21/5 divided by -10/3. Okay. So if we look at the example in the textbook here, they show you how to use the what I call the fraction method to solve this answer. So over here, they've converted it to -21/5 divided by -10/3. What they're going to do, what they kind of didn't show this step very well in the textbook is, oh, whoops, sorry. Oh, they are doing it. So actually the textbook's showing the other way. So what we're going to do here, and they showed the results of it, but they didn't show the step. They kind of didn't give us the rest of the owl here. And so what we have to look at is how they actually solved it. So the second method, as shown here, is that we basically take our second number, and even though we're dividing it, what we're going to do is reciprocate it. That's why I boxed up this box over here. So we're going to flip it upside down. So that gives me -3/10. And because we flipped it, we're also going to multiply now. So what I have, instead of -21/5, instead of divided by 10/3, what I actually have is multiplied by -3/10. We already know how to deal with this. This is pretty straightforward. We learned it last time. We're going to multiply both our numbers straight across. So I get 21/3 is 63. 5 times 10 is 50. And that's where 63/50 comes from. I actually misread this question when I was looking through the textbook before this lesson here. So this is the second method. You have two different methods, what I call the fraction method, where you get them over top of similar denominators, and then you take the top two numbers, rewrite them as a fraction, and that's your answer. Or we have the reciprocal method, where instead of dividing, you actually flip the fraction on top of itself or upside down, and you multiply. Okay, so what if we don't have fractions? What if we have decimals? Well, our math here is pretty simple, but there is one thing that I like to show here. And I'll be completely honest, at this point, you should be able to punch that into your calculator. But the one thing that always bothers people, this example too, you can punch this into a calculator. The big question I always get is, how do I put negatives into my calculator? When you're multiplying and dividing, don't. It's not even worth it. It's a little bit more important, it's a lot more important for adding and subtracting. But when it comes time to it, just look at our rules. I know that I've got different signs here, so it doesn't matter what happens. That one's coming out negative. I have same signs here, so no matter the answer, I know that it's going to be positive. Now, I don't have to worry about second functioning or hitting any extra buttons on my calculator. All I have to do is just punch in the numbers as they appear. Yeah, so that's what they're giving you a reminder of right here. Now, last time I pulled up the calculator on this thing, it went a little haywire on me, but let's try it now. All right, so we have 1.38 divided by 0.6 is going to give us 2.3. Okay. So our answer here, let me close this. That's why it went haywire. I forgot about that. Okay, so our answer for this one is 2.3. But again, because I have opposite signs, I know that it's going to be -2.3. Okay. Now here's a little example I want to show you. If you don't have a calculator, there's a somewhat easier way to look at these. And this is a handy rule to use when we get to some other lessons in math as well. But I can manipulate decimals, right? So I don't like 0.25. I'm much more comfortable dealing with 25. So what I've essentially done is moved my decimal over 2 places. So what I'm going to do is whatever I've done on one side, I have to do the other. So for this one, I'm also going to move this 2 places. So now what I have is 25 divided by 30. Right? If I want, I could rewrite this as a fraction, and I can reduce it so I get 5 over 6, and I know, or then I can punch 5 over 6 into my calculator and figure out what it is from there. So let me pull that up. Okay, so I can go 5 divided by 6. Oh, I should put this down. 5. I'm gonna have to delete those. All right, 5 divided by 6 equals 0.83. Looking at if we punch in our original one here, so we have 0.25 divided by 0.3, I still get the exact same answers. So I can manipulate decimals a little bit. If I don't like dealing with the 0.25 or 0.3, I can move decimals and give myself some bigger numbers to work with if it's a little bit easier for my brain to handle. Okay, so those are a couple methods for dealing with decimals numbers, though you should essentially just be punching them into your calculator, but you have to understand where those different signs come from. Okay, so now we're going to look very quickly at a little bit of a, not a mind bender, but a different way to think about mathematical problems. So what they want you to do is understand the relationship between dividing and multiplying. So what we have here is a division statement. Some number divided by negative 2.6 equals 9.62. But we don't know what that number is. Oh my goodness, it's an incomplete equation. Everybody panic. Well, no. I know that the opposite of dividing is multiplying. So what I'm going to do is basically just do this whole equation in reverse. So I now have 9.62 times negative 2.6 equals. So I've reversed the equation and inverted my operation. And instead of pulling up that busted calculator, I'm going to do it on here. So I have 9.62 times 2.6. Too many things on the screen. 9.62 times 2.6 equals 25.012. Okay? Now I can also do the exact same thing with fractions. Okay? So I don't know what this number is, but what I need to do is invert. So I'm going to do the opposite of dividing, which is multiplication. So I'm going to multiply these numbers. Negative 15 over 56 times negative 5 over 8 equals, so we multiply this straight across, 15 times 5, 75. 56 times 8 is too big for me to do in my head. 448. A big number. And I could even, if I wanted to convert that to a decimal, I could, but that's not a big one. So that's my final, or not quite, I have to reduce. I believe 75 divided by 3. Not quite. Not sure what number exactly off the top of my head might reduce that down. We'll save that for later. Actually, you know what? That's going to be the brain push-up for the next classes. I want you guys to figure out if that's a prime number or if I can reduce that down. Okay, that's class for today. See you in class.